Good afternoon or morning, yeah. Good time of day. I'm Lionel Ferret, working for the Belgian National Cert, and I'm your session chair for this morning. Our next and last presentation of the morning, standing between you and lunch, is Maddie Stone, from researcher at the Google Project Zero. She's got a presentation about zero-day exploits seen this year. So this is going to be quite entertaining, I believe. Please remember to turn off your noisy devices. Please remember also to fill in the surveys in your mobile applications. There will be 4 questions. There are mics scattered in the room. You've seen them. So without further ado, let's give her a warm welcome.
Good morning or afternoon. He stole my joke about standing in between y'all and lunchtime, but, you know. So yes, we're going to talk about the zero-day exploits that we've seen actively exploited in the wild so far in 2022. My name's Maddie Stone, and I am a security researcher on Google Project Zero. So before we dive further into this, let's make sure we're all working from the same definition. What is a zero-day exploit? So the definition that I'm using is one where it is an exploit that is exploiting the vulnerabilities that defenders don't yet know about. So these are the ones that we don't realize there's a hole there, there's no patch available, there's no specific signatures or detections to find it. So you're basically trying to protect people from vulnerabilities you don't know actually exist. And that's why I think it's fun. And it matters a lot. It feels like every single week we're seeing new headlines about zero-day exploitation. And while zero-day exploitation as an absolute number of attacks might not be all that large, we believe they have an outsized impact on society. So even though me, you, certain organizations may not need to individually worry about these zero days, it affects us when they're targeting our journalists, our government officials, our human rights defenders, critical companies. All of that, those attacks still come back and change the way, influence our lives. And so, I walked too far away. So that leads me to my team, Google Project Zero. Our mission is make zero-day hard. We want to protect users from the harm that comes with being exploited by zero days. Project Zero has primarily worked towards that mission through offensive security work. Our team finds new vulnerabilities, hoping to collide with the attackers, meaning find the same bugs, but instead of exploiting them against people, we go ahead and report them and get them fixed. And this is not just for Google products. We do it for basically any products that have a large global consumer customer base. So we do this for Apple, Android, Chrome, Firefox, et cetera, et cetera. And while that's what most of my team does, I work a little bit differently. For the last 3 years, I've led a program that is focused on the zero days that are actively exploited in the wild. So not the zero days that could be exploited and were found by security researchers, the ones actually used against people. And the goal is to then learn as much as we possibly can from those zero days, to then influence new structural improvements or exploit mitigations or things like that and make zero-day hard. So I always want all the data and my conclusions to be peer reviewable or for y'all to be able to contribute or use it however you want. So all of the zero days I'm talking about today, we track in a public spreadsheet going back to mid-2014. And we also have a public GitHub repository that we try to have be a central repository to find anything or all the details about zero days that are actively exploited in the wild. And so since I started this, there's been a whole lot more zero days detected and discovered. So I do take pull requests too, if you would like to perform some of these analyses. So getting back to make zero-day hard, what does that actually mean? We want to, or we can sort of break it into 2 different things. First, we want to increase the cost per exploit Cost not meaning price. Cost meaning money, sure, but also the time and the expertise required to build these zero-day capabilities. Are you able to, have a new grad come, never looked at the attack surface before, but spin up for maybe 3 months and have an active zero-day exploit? Or does this require someone who has been focused solely on that attack surface for years and years and years for them to be able to build that capability? That's what we mean by increasing the cost per exploit. And the second part is then increasing the number of exploits required to maintain the same capability. So currently today, if an attacker wants to have a capability where they want to remotely infect a phone, where the user clicks a URL or a link and it opens in their browser, they largely need 3 0 days, each of them exploited and then chained together to get that capability. You have your renderer from the browser RCE, remote code execution, then you need your browser sandbox escape, and finally the local privilege escalation. What harder will look like is that we've added so many more security boundaries within there that now to maintain that same capability of you have a user click a link and then can remotely own their phone, we now require 5 is to have that capability. So that's an example of making it harder. This is also some more descriptions of what it will look like when zero-day is harder. Attackers, to have their capabilities, will have to discover whole new bug classes. They're not going to be able to use the use after freeze and the buffer overflows and all these patterns and shapes that we've been seeing for years and years and years. They're going to have to do something really novel to be able to find a vulnerability. They're going to have to work on attack surfaces that don't have documentation yet, that there is not previous research on, that they can just build upon. They're going to have to find something new that no one's thought of as an attack surface yet. They're not going to be able to use their previous or others' previous exploitation techniques. Because to have a zero-day exploit, it's not just having that zero-day vulnerability. You also have to come up with a way to exploit it and make it useful. And so coming up with ways that they can't just plug and play a new vulnerability into their existing exploit framework. Because it's generally accepted that vendors should fix vulnerabilities when they're reported to them. It is not yet standard that vendors will mitigate exploit techniques that are used. And last sort of example of what it will look like when zero-day is hard is that exploits will only be used very selectively in the most highly targeted attacks. Some of y'all might think this is the case now, and while yes, 0 days are used in more targeted, more selectively than, say, in-days or phishing, we don't think that it's selective enough. It shows us when attackers are willing to use these 0 days in things like watering hole attacks, where they will infect every user who goes to a certain website because they want to attack a whole population of people. If they're willing to burn it by spreading it that widely, then that means it's not valuable enough to them. It means they have too many options in the background to replace with it. And so that's why we need to see it used more selectively. So if that's what 0 day looks like when it's hard, spoiler, currently I don't think 0 day is hard. And the reason being, when we look at these 0 days from 2022 thus far, there have been 18. 9 of those 18s are variants of previously patched bugs. They look very close to bugs we've seen before and that have been reported to vendors. On top of that, 4 of these 18 are variants of In-the-Wild 0 days from 2021. So we detected them, the industry knows about them, they were disclosed, and yet the attackers were able to come back generally less than 12 months later and have a whole new 0 day capability because that was not patched completely and comprehensively. And this stat hurts. It hurts me a lot. And maybe it's because I've been studying 0 days in the wild for the last 3 years, and I'd love to be able to say, it's making this difference, which this stat makes it harder to say. I'll still hope I'm making a difference. Any manager who may watch this and is in charge of my perf. But it is a failure case for attackers if we find and detect their 0 days. And so as defenders, we want to capitalize as much as possible on that. It's highlighted with a yellow thing saying someone was able to exploit this and did. So let's use that information to block all the others. But that wasn't the case for 4 of these. And I think it's also hard because this is not the first time we're talking about how variants are able to be used successfully as zero-day exploits. We actually wrote in our Project Zero 2020 year in review of actively exploited zero days that then 25% of the zero days detected in 2020 were variants of previously patched bugs. So this is seeming to be a long-term trend. So before I get into how can we possibly address this problem, I first want to show you what does it mean? How close are these when I'm saying they're variants? What went wrong that allowed them to be exploited again? I know we have a mixed audience here, so if vulnerability research is not your thing, just bear with me. I promise the slides of code will end before you know it. So the first one we're going to talk about is actually the first zero day that was disclosed this year. It was patched in January, and it is a bug in Windows or Win32K. So this 2022 in the wild was patched in January, as I said, and it is a very close variant to a in the wild that was patched last February in 2021. Turns out it's the exact same bug, just triggered in different ways. So the bug is that it's in Win32K, which is a kernel driver in Windows that's responsible for managing the graphics and the windows you see on the screen. And because Win32K has to manage that, there's a lot of transfer of information back between kernel space and user space. And so Win32K manages that. This bug class that this bug is called the user mode callback bug. It's actually super common. One of the best resources, I think, on it is a 2011 Black Hat talk. So this has been talked about quite a bit. So in particular, for this bug in Win32K, we need to start with the tag WND or tag win struct. And so the field that we care most about is the CBWND extra field. Because tag win can have a flexible size. It's not always the same size. It can have extra bytes based on the type of window that it's representing. Oh yeah, because the tag win struct is the kernel structure representing any windows within the operating system. So we have this field that tells us how many extra bytes should be in the structure. Now this function, XXX client alloc window class extra bytes, is responsible for allocating the extra bytes. That really rolls off the tongue, so instead of repeating it a whole bunch, I'm just going to call it Jerry. Jerry has 2 different functionalities. One when it's a regular window, and one when it's a console window. We're going to talk about the regular version of Jerry's behavior first. So Jerry will allocate the number of CB-Win extra bytes in user space. Jerry will then return a pointer to that user space allocation, and that is stored in the tag win struct. But there's other types of windows besides this regular or default. One of them is a console window, and you can make a regular window a console window by using this function int-user console control. It just sets a flag in the tag win struct that tells them, yes, this is a console window. So when it's a console window, instead of being allocated on the user space, the bytes are allocated on the kernel heap. And not only that, but instead of returning a pointer, they return an offset from the base of the heap. And this is where the type confusion comes in. So to trigger the bug, you create your regular window, and you set this CB-Win extra field to a custom value number of bytes. Jerry then allocates that number of bytes on the user mode heap, because we're still a regular window at this point. But then Jerry has a user callback. That's what the XXX before function names in the Windows kernel mean, is that there is user code execution sometime during this. So during that callback, Jerry has allocated our bytes on user mode, but we're going to call int-user console control and change it to a console window. When we return from our code execution in that callback, Jerry doesn't check the status. It just will go ahead and still return our user mode pointer that it allocated. But the kernel doesn't see that. The kernel checks the flag in the tag win struct is like, hey, this is a console window, so this is an offset from the base of the kernel heap, and then we have an out-of-bounds read and write, which was the out-of-bounds read and write was then used for a local privilege escalation. So what the heck happened here? The first 2021 in the wild triggered the bug through a function called createWindow. That was the path it followed and ultimately called Jerry. The patch only modified createWindow to protect against this bug. But Jerry has lots of friends, and Jerry can be called a whole bunch of different ways. So the 2022 In-the-Wild exploit came back, triggering the same bug, just calling it through a bunch of different other methods. So the new patch for 2022 seems to get better to that root cause of the issue being within client alloc window class extra bytes, our good friend Jerry, and checking the flag and seeing if it changed after the user's code execution. Our next case study is IO mobile frame buffer, which is an iOS attack surface. And so this bug was also patched in January in iOS 15.3. And it is a very close variant to an in-the-wild that was patched in 2021. Even though Apple did not originally flag this as in-the-wild in their release notes, it had still already gotten quite a bit of attention because it was used by the Pengu team at the Tianfu Cup, which is the Chinese hacking competition, to hack the iPhone 13. So it's still been in a lot of vulnerability conversations. My team, Project Zero, as well as Google Tag Threat Analysis Group, actually just published blog posts on this exploit and how it was used last week, so if you're interested. So what is IO mobile frame buffer? It is responsible for managing the screen frame buffer on iOS and macOS devices. And it's been a target of interest. There were also 2 other in-the-wild vulnerabilities in 2021 in this because it's generally accessible from the app sandbox, which makes it interesting to target. The other sort of interesting thing about it is that it lives in different places depending on the device. On iPhone 11s and earlier, as well as Intel Macs, it's a kernel extension, whereas on iPhones 12 and 13 and M1 Max, it lives on the digital coprocessor. So the exploits we saw in the wild targeted it in the DCP. So the issue is in this function, uniformity compensator set, in which uniformity compensation is responsible for addressing inconsistencies in like the display. But we don't really need to know about that because that's basically all I know about it. And the issue is it's a standard buffer overflow. The same things you saw in your class a decade ago about security, or more than a decade ago, is the issue here. We have the controlled size, user-controlled, attacker-controlled size, that is passed directly to memcopy with no bounds checking. Pretty standard vulnerability. And the fix that Apple published for this was to add a bounds check. They make sure that controlled size will never be greater than hex 41, preventing the buffer overflow. However, that's just an upper bound. There was no lower bound also added there. And it turns out the next block down in this function is still using controlled size, but they're first doing some subtraction from the controlled size and then using that difference from the subtraction to access memory and write memory, which then leads to another buffer overflow if, say, your controlled size is 0, and you subtract 1 from that, and now you have XFFFFF, and controlled size is treated as an unsigned int then to access your memory. Once again, you're out of bounds read and write. So to fix this, they added the lower bound, which seems sufficient. So our last case study, you're almost there, is a Chromium Bug. So this one actually has quite the saga, going all the way back to 2016, when a researcher, who is now my teammate, Sergey Glazunov, reported just normal bugs in Chrome then. Then we had the 2021 in the wild patched in June, and then we had a 2022 in the wild patched in March. And that wasn't the end of it. Sergey was looking at the bug because he thought it was an interesting one and noticed that the patch was not complete. There was a way to still trigger the bug, and thus there was a 4th patch issued. So these are all property access interceptor bugs. What those are is basically a method that is run every time a user tries to access a property of the object in JavaScript. So we're here in JavaScript land right now. And where the issue comes in is that this can lead to user JavaScript execution during property assignment. Not before, not after, but actually during when you're trying to assign a value to a property. Which, if the code then doesn't check the state of that object and property after the user's JavaScript runs, then that means that the object can be left in a corrupted state, which could then be used for universal cross-site scripting or type confusion for remote code execution. So the first 2016 bug was the property access interceptor for this HTML embedded element. And basically, it allowed access to properties belonging to a different website, which that was then used for universal cross-site scripting. The 2021 in the wild was also in the interceptor for HTML embed element. But in this case, if the object didn't already have the property within it, then the user's JavaScript code was executed. The user's JavaScript code could say, hey, I'm going to add this property since it doesn't exist. But because once that returns, the Chromium code did not check, hey, what's the status now of this object, and still assumed that that property didn't exist, it would then add the property a second time, which then left the object in a corrupted state, which could be used for RCE. And the 2022 in the wild was very similar, but for CSS style declaration. And the main difference when it comes down to is that the first one triggered this when the property was in the JavaScript object's prototype chain. So JavaScript experts wouldn't want me to say this, but sort of think inheritance if you're not a JavaScript person. Whereas in this case, it was a different flow because they triggered it, the property belonged directly to the object, which turns out is a different execution flow. And this is much more obvious when we look at the patch. So this is the function where all of these patches were happening. And this is the interceptor block of that. So the first fix is down here. And the part we care about is that bottom line that says set super property. Because that's the function that knows how to handle if the object's state changed. It does all the checks and knows there. But the issue is that if you see here, that set super property call is only in this else block. So it turns out if the property is owned directly by the object, then we're in that if block and won't hit that set super property. So the next fix was to move the set super property down one level so it would be hit by both the if and the else blocks. But that wasn't the end of the story. Then Sergey noticed that there was still a way to hit the bug. This time, just instead of saying property equals value, you use the object.define property call. Because it turns out set property internal where they put the patches was only used if you were doing property equals. So this is what you had to change to have a working proof of concept again. No longer style.prop equals, just object.define property instead. So those were 3 case studies, and my hope is that you see just how close these variants are. This is not what makes zero-day hard. This is not talking about zero-day hard, because it's really just looking at what changed, what was the fix, and identifying, oh, hey, I can still hit that and exploit it, and then they have a zero-day exploit capability again. And as I said at the beginning, there were 9 total variants. So these were the other 6 that we didn't cover. And I think what's most stark about this is it shows it is not an individual vendor or an individual product issue. Across the industry, we're having trouble making the most of the vulnerability reports that are coming in. We're not correctly or comprehensively getting all these patched. In some cases, the patches are just being regressed, so it's the exact same bug again. In other cases, the bug exists in one subsystem, and it's only patched in the other, or they don't see it in another, etc. So what do we do about it? correct and comprehensive patches. And I don't say this to be glib or to minimize the very real challenges that vendor security teams are facing. They would love to have all the resources, time, incentive structures to be able to spend large amounts of time diving into each individual vulnerability. But that's not what they're currently given right now. Triage has to be quick, and there is a very real tension also between protecting users quickly and getting a full understanding of the bug and complete solution to mitigating it. But that's where I hope we can all see that patching or releasing a patch really shouldn't be the end of our vulnerability triaging, our vulnerability response or exploit response, because there's so much more we can learn from each of those. But on the hopeful side, at least I think it's hopeful, is that this doesn't have to be a situation where you have to do every single thing to get any return on investment. Because any incremental progress we make on better patching these vulns, we will see that return on investment in making zero-day hard. So each individual step matters a lot. So correct and comprehensive patches is really amorphous. It's easy for me to talk about here on the stage and say, hey, just here's what's wrong. So here are some of the suggestions I have for actual steps that might make sure a patch is the right fit or we're making the most out of each vuln report. So the first, hopefully it's obvious, is doing a root cause analysis. The root cause analysis is really digging in to make sure we understand what is the bug at the end of this. What was the mistake that was made? Not just the execution flow that the exploit does, but where is the mistake? Because then that leads us into variant analysis that says, okay, so where else might this mistake exist then? Do we need to change our automated systems like our fuzzers that they didn't find this? Do we add in new code so it will find bugs like this? Or is this actually highlighting there's real underlying design flaws in this attack surface that we need to prioritize code auditing on it? That's where variant analysis comes in. Patch analysis also requires root cause analysis done at the end, and it's looking at, okay, is this patch actually addressing the underlying vulnerability here versus a Band-Aid to just block the exploit we know about? One thing here is most vulnerability reporters to any vendor security teams would really also like to have the vulnerability fixed on the first time. That's our preference. And so sharing and reaching out to your reporters and saying, hey, this is what my plan is to patch this, we would love to have that conversation early and prior to you doing all of the cycles to spin a release, testing, and stuff like that. So that might be one way to help. It's also nice because these three things, as long as there's transparency from the vendors that we're leaning on, are things that Project Zero does or any other external security teams can take part in as well. And especially with these in-the-wild 0 days, more eyes with more ideas for how to confront these problems is only that much better. And if you are, say, a customer of one of these security vendors but are not in the place to perform these analysis, we could also really use you asking the vendors of, hey, can you explain to me what your triage process looks like? Are you transparently disclosing if you know that 0 day is exploited in the wild? What type of variant analysis are you doing? Or if you see in the press, because someone posted stuff talking about variants for one of the products you use, ask them, just how did this happen? What are you going to do differently? Because I think what it really comes down to is we need to show a lot of these software vendors that this is an expectation and a minimal step, and thus incentivize your security teams and give them space to be able to really dig in and do a lot of these steps. The last are 3 other ways to really make the most of any 0 day in the wild or vulnerability report, of not just stopping at, okay, we patched it, let's move on to the next one. What are detection techniques? But not detection techniques for this one. What can this teach us about detecting other 0 days? Does it turn out there's a step that will likely be required for any of them? A certain heap grooming required in the product or something like that? How can we block the exploit mitigation? And lastly, overall, what could be some hardening and systemic improvements that would make this much more difficult in the future? And the last step in things that will really help is transparency. There has been distinct improvement in this in the last couple of years. For example, last year, 2021, was the first time that Apple and Android would actually label in their release notes if they had evidence to know that something was in the wild. But there's still a lot of progress to go, and that is still not an accepted industry standard. So talking to your customers, asking what type of information they're publishing. Are they letting you know if something's in the wild and known to be actively exploited? What type of technical details are being shared so that other security researchers can try and help and analyze the patch, figure out the bug, come up with fuzzers or automated solutions? So ultimately, hopefully we can continue making zero-day hard. I'm hoping to see changes in the trends for the second half of 2022, maybe a few less variants and a lot more fun things that are brand new to tear apart. But yeah, it's going to take us all to get there. So thank you. Any questions?
Thanks for your talk. I like your aspiration to have 0 days, but I guess my concern is around legacy software products which aren't maintained. And so what's your view on that from the legacy perspective, please?
Yeah, so legacy software is a really large problem, and it just doesn't tend to be where we're focusing, because there are a lot of folks focusing on that as well, because this is that case of we don't use 0 days as an absolute metric for security, because if you can use in days or phishing or malware to get in, then sure, you have 0 days that are being put in the press or are labeled for you. But it's because folks were able to get in with much less sophisticated solutions as well. So yeah, it's a huge issue. You know, things like the Internet Explorer deprecation, we still saw 4 Internet Explorer 0 days last year. And so it's finding ways to be robust enough against it.
I actually have another question. I like that you said that we could try and ask vendors for what is their triage processes, how do they look for variants and so on. My question is, do you really think that if I ask Apple, Microsoft, Meta, or Google, they will answer?
So I think it largely depends on how much money are you spending with each of these vendors. And that's where I sort of say, I know some of y'all are really our enterprise customers. I am not. So as a user, if I just went up and said, hey, share all these things with me, what benefit is there to them? But if you're a customer and saying, hey, this is what I expect from if you're going to get my money, then I think that's where some of this change can happen, and trying to just get this industry momentum to make some of these as more standards.
Okay.
Thank you for a very interesting talk, almost unsinkable, I would say. I'm asking devil's advocate's perspective questions, so don't kill me for the question. But if CVEs and zero-day reports are all it takes for inspiration for an attacker, how good is the transparency about this? Wouldn't hiding the patch and keeping silent about patching also improve the situation?
So no, and my answer is very clearly no, and the reason being is that these shops that are building these zero-day capabilities, they have tons and tons of people whose whole job is every time there's a security update, they binary diff it and patch diff it. So the attackers already have all this information. It's just then on defenders, I don't have that same purview to be able to do that every single month for every single product, because there's just not resources as defenders. There's not the same return on investment as it is for these commercial surveillance shops and others who are building the zero-day exploits. So by making it public, we're making it so defenders just have that information in addition to what the attackers already have.
Okay, so thank you. You've been a great audience. Maddie, thanks again for the presentation. Please, thanks Maddie last time.
Thank you.